Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. Dear learners, we are going to solve question number 3 of exercise 12, which is on page number 188. Question number 3 is saying that describe simple experiments to demonstrate the following. Number A part. A dull surface is a better radiator of heat than a bright surface. For that, we are going to consider this figure in which there are two tins. One is a polished surface, which is on the left of your screen, and the second one is a black surface. And there is a water inside both the container, and that is filled till the brim. Ladies and gentlemen, if we are putting these two containers in the sunlight, for example, this is the sun and the radiation is coming here to the polished surface as well as to this dull black surface. Because dull black surfaces are good absorber of heat, so it will absorb the heat inside this, and as a result the temperature will rise very soon. And similarly, because the shiny polished surface are good reflector of heat, so very little heat will enter, and most of the radiation coming from the sun in the form of electromagnetic radiation will be reflected, and very little change will be there in the mercury level in this tin. So this shows that shiny surfaces are good reflector of the heat, while black surfaces are good absorber of heat. You can see that from the mercury level of two different thermometer, which is labeled as T1 and T2. Okay, the second part of this question is saying good radiator of heat are also good absorber of heat. So let us do the same. Now we are bringing this setup to the shadow. For example, there is a shadow here, and you will see that because dull black surfaces are good emitter of radiation as well, so it will allow to radiate the internal energy or heat so quickly. So you will see that there will be a very rapid change in the mercury level, and that can be visible from the thermometer. And in this case, because shiny surface are not that much good emitter, so it means that there is a little bit absorption will be there, and they will reflect most of the energy back and a little bit will escape out. So, ladies and gentlemen, you have to keep in mind through these two experiment. Number one, a dull surface is a better radiator of heat than a bright surface. And in part number B, good radiators of heat are also good absorber of heat. Okay, now we are turning our focus to this question number 4, and I wrote all these things in advance for you people, although I got very long time for it because I don't want to waste your time. So the A part is saying what is radiant heat, and we studied that heat due to infrared waves is called radiant heat because the radiation coming from the sun in the form of electromagnetic waves from the spectrum, we can see that there is a very small portion of visible light. On the left side there is ultraviolet radiation, and on the right side there is infrared radiation beyond red, and that infrared radiation causes temperature rise or heat. The heat due to infrared radiation is called radiant heat. The B part is saying why are space suits or firefighting suits covered with a shiny metallic surface? Yeah, because shiny surfaces are poor absorber of radiation or heat. So much heat will not be absorbed by that metallic shiny surfaces, and much of the heat will be reflected, so the body of that worker will be safe from the heat and bad radiation in the space suit or the fire worker as well. The C part is saying why are car radiators or motorcycles engines fitted with cooling fins that are painted dull black and have the largest possible surface areas. Black color is a good radiator as well as a good absorber of heat. So the radiator is colored black, so that the heat generated by the engine is radiated efficiently due to the dull black paint. Why the largest surface area will radiate a large amount of radiant heat because it depends on the surface area as well. Smaller surface will radiate small amount of radiant heat, while the larger surfaces will radiate large amount of heat. That is why they are made of what? Of larger surfaces. Okay, ladies and gentlemen, there is a question number 5. In question number 5, the figure you are seeing on the right side of your screen now is of Thermos Flask. The diagram shows a simple vacuum flask. Explain how the design of the vacuum flask help to ensure minimal heat losses so as to keep drinks hot. Dear learners, we discuss that topic in greater detail. If somebody is seeing my this lecture for the first time, he or she can go to the previous lecture and can study it in greater detail. So let us discuss it here for your convenience again. To minimize the heat losses in four possible ways. There are four ways. They are conduction, convection, radiation, and evaporation. Yes, evaporation is also there, and we will discuss in a moment that how. Number one, conduction and convection prevents heat loss by the vacuum between the double glass wall of the flask. So if you can see that there is a zoom part of this double wall glass, one thing is that there is trapped air inside these two glasses, or it is a vacuum. So it means that air is a bad radiator of heat. It is playing the role of insulator, which is preventing heat to flow out of the flask. One thing. The second one is that you can see that the walls of the glass are painted silver. So it means that it is a good reflector of heat. So internally it will reflect heat. If some radiation is going out from the first wall, they will be reflected back by the second wall, and as a result the liquid inside the flask will remain in its hot condition. So the first part, conduction and convection, prevent heat loss by vacuum between the double glass wall of the flask. The second one here is saying conduction through the trap air above the liquid, which is, for example, this is the liquid, so there is air above that liquid, and because air is good insulator of heat, so it will prevent heat from the hot liquid. Now one thing more, that there is another arrangement, and that is that stopper. Stopper is usually made of plastic, which is a poor conductor of heat as well. So another design strategy is to reduce or minimize the heat loss. Now radiation and conduction will take place only when the stopper is removed and you want to use that liquid inside that. So in that case the heat will escape out from the liquid. Now this stopper is usually made of plastic, and in many cases it is also made of cork, so that is also a poor conductor. Now in this case, to minimize heat loss through radiation, the wall of the glass are silvered so as to reflect the radiant heat. So all these things we studied in the lecture. If somebody want to learn it, go to the previous lecture and find it. Now very interesting question is here, and that is in the form of question number 6. Let's understand first the question, keeping in mind this figure. Let us read the question first. The diagram shows a method sometime used at open air camp of keeping food warm overnight. In the evening, food is heated in the metal pot, which is then placed in the wooden box so that it is surrounded by loosely packed hay. Remember, the keyword here is loosely packed hay. Keep in mind. The next morning, when the metal pot is removed from the hay, the food is still warm. That is the question. The A part is saying, explain how the loosely packed hay reduces heat loss from the food. So, loosely, I wrote it here for you in advance that loosely packed hay means that there is air between the hay, which is good insulator of heat. It will minimize heat loss. Also, the box is wooden, which is also insulator, and that will also not allow heat to get out from the hot pot. So the food stuff will remain hot when you are checking at next morning. So this is the answer of part number A. Now part number B is saying state with the reason what is likely to happen if the hay is tightly packed. Because in the question they told us that the hay is loosely packed, so there will be air trap inside that, and air is a bad conductor of heat and a good insulator of heat, so heat loss will be minimized. Now if you are pressing the hay particles, so it will remove out the trapped air, and the hay will now behave like a solid. When it is behaving like a solid, so heat can flow very, very easily in the solid form, because we studied that the hot side of the material will push the neighboring molecules and will transfer the energy. So from the hot pot, the energy will go out towards the walls of the box. Whatever box is doing with that energy, we don't have any concern, but it is getting out from the hot pot, and the food will not remain that much warm if you are pressing the hay. So that is the reason that then heat will flow and the hot pot food stuffs will not remain warm. I have written here, let us discuss that as well. If the hay is tightly packed, then air will not be trapped and the hay will behave like a solid, and heat will be radiated and the food will not remain hot. So that was the question number 6. Now we are turning our focus to very important part, and that is all about the radiation and conduction. Question number 7 is saying a solar panel converts energy arriving in the form of electromagnetic radiation from the sun to heat internal energy of water. There are water pipes, you can see it here. So the main purpose is to heat this water, and we have to convert that heat energy coming from the sun. One type of solar panel, that is a specific type of solar panel, fitted to the roof of a house is shown in the cross section in the diagram, which you can see, and we will discuss that in a moment. But let us first understand the part A of the question. What is the name of this type of electromagnetic radiation? Remember, dear learners, that sunlight energy that reaches the ground contain 4% of ultraviolet and 43% of visible light, and similarly 53% is infrared radiation. So the panel is converting mostly infrared radiation, and the electromagnetic radiation which is used here, the name is infrared radiation. That is infrared radiation. I am writing it infrared radiation. So remember, the part A answer is infrared radiation, straightforward. Number B part is saying, in which number 1 part we will discuss one of the surfaces X and Y. This is X surface and this is Y surface, is painted dull black and the other is covered in aluminum foil. One is dull black and the other is in aluminum foil. Now, section 1 of part B is saying, state which of the surface X and Y is painted dull black. Give a reason for your choice. Ladies and gentlemen, dull black surfaces are good absorber of heat. So it is absorbing the heat, and aluminum is a good conductor of heat as well. So first the X will be painted with black. It will absorb the infrared radiation efficiently, and then it will pass it to the aluminum foil, and then aluminum will conduct that heat to make the water hot. So X is dull black and Y is what? That is silver. Both are playing their roles in warming the water. So one is dull black and the second one is silver. So I wrote here, dull black surfaces are good absorbers of heat and aluminum is good conductor of heat as well. So maximum energy will be converted to heat. Yes, that is the main reason of that. Now the second section of part B is saying, why is the front sheet made of glass? Explain how it achieves its purpose. Ladies and gentlemen, as we discuss in the greenhouse effect, exactly in the similar fashion, here the glass is playing the role. So I wrote here that thing, when electromagnetic radiation is coming from sun, the radiation is of short wavelength that can pass the glass, but when absorbed by the surface it becomes of larger wavelength that cannot escape out from the glass, and more heat is trapped inside it. So this is another arrangement in a specific type of solar panel which is used to make the water warmer. So glass is playing the role of greenhouse here because the radiation coming from the sun is of smaller wavelength, of higher frequency, so it can pass through the pores of the glass. When it is absorbed by the area inside that glass, it will also emit electromagnetic radiation, but that radiation will be of larger wavelength because the source of sun, the source of electromagnetic radiation coming from the sun is so huge that you cannot compare it with the electromagnetic radiation radiated from the surface. So it will trap that radiation, and as a result it will make the water warmer. So this was the whole story about question number 7. Now we are talking about question number 8, and that is the final question of this. Ladies and gentlemen, if you remember, we discussed the household boiler system in the last lecture. That question is testing your knowledge of that boiler. So the diagram is given on your screen. I copied it exactly in the same manner as it is given to us. So the question is saying the diagram shows the essential features of a domestic hot water system. Number 1, what is the name of the process by which the hot water rises from the boiler to the hot water tank? Remember that there is burner here, and when this part of the water becomes warmer, so its density is reduced, and as a result it move upward. and the convection current will be produced, and that will move from here to the upper part of that boiler, because it is uh, divided into two parts. This is a hot and this is a cold water supply. So here it is hot, and in the downward portion there is a cold water. So which process is responsible for it? That is convection. Okay, that was the first part. The second part is saying that does the heated water rise to the hot water tank through pipe A or pipe B? This is pipe B and this is pipe A. I already shown you that this hot water will go through this pipe A to the hot water uh, chamber of that boiler, that is called hot water tank. So through pipe B I have written here the answer. The third part of this question is saying what is the purpose of pipe C, which is this one, and we discussed that it is called overflow pipe. That is overflow pipe. If by certain reason in the boiler the water becomes so hot so that it is moving higher, then it will come back to the Saturn, and that Saturn will reserve it, and it will be mixed with the cold water. So after some time it will also be cold, and then you can resupply it through the pipe D here to the cold section, and that cold section will replace that hot water which rose up in this portion. So at the bottom there will be cold water, and at the top there will be hot water, and that is due to the convection process. Now the D part is exactly pointing to this point. What is the purpose of pipe D, which is this one? And I told you that point D is to supply cold water to the boiler. It is coming from the Saturn, and it is coming to the cold chamber of this hot water tank, and from there it will fulfill the vacuum created by the hot water, so that the water will go in upward direction through convection process. Ladies and gentlemen, it took very less time to explain it, and it took very long time for me to write it, and that is why I wrote it in advance for you people, so that I should explain it in front of you. If I am writing it in front of you, it would take longer time, and that was the mean that I wrote it. So with this question we came to the end of this chapter. Tomorrow we will start a very important, and many students of mine as well as many teachers are discussing with me that waves chapter is a bit difficult, but it is not. It is absolutely nothing. We will discuss it, so stick with me. Tomorrow we will start topic number 13, which is general wave properties. So thank you very much for your time. Have a nice time. Allah Hafiz.